Now let us take the reference signal into account. Until now we have the block diagram only with this part. So there was no reference on the left, which now I just put with green value. Until now, with the state feedback control with K transpose, we just can do that. The system is stable, the system can be faster, and so on. So we could change the behavior of the transient of the system. Now we should go further, next one step further, which is the calibration factor. And this calibration factor is used to take the reference into account. So on the left there is a reference signal, for example a stepwise signal, and we need a calibration factor to take this into account. In this case, the input of the system is U. The U is minus K transpose X. This part is coming from the state feedback, and there is another one input KR multiplied by R, and R is the reference signal, and we need a calibration factor. Okay, so what are the steps of the design? The first step is the pore placement, so we can design K transpose, for example by Basgura or by Ackermann, and then we have to choose KR according to this equation, and here I am not going to prove it. KR is minus 1 over C transpose and the inverse of A minus B K transpose multiplied by B. This will be the calibration factor. If we set the calibration factor by this equation, we will have the result of the following. Here, as a black box, I just draw the closed loop system. The closed loop system with the input of R here and the output of Y here. This is the output. So if the input is 1 of t, so it's a step function, then the output will be something like that I draw to here, which is going to approach the value 1 at the output. If we don't use KR, so KR is equal to 1, for example, in that case our signal at the output will be something like this, which is very similar to the black one, but there will be a very big error at the end of the output. So this difference can be disappeared by the use of this KR, because the goal of KR is to decrease this difference to 0 if the input is exactly the signal of 1 of t. There will be a more clever way which use integral, and this is what we are going to speak about in the next video.